What if a car could drive itself perfectly without a human behind the wheel? Every turn, every stop, every decision, trained in data labs before hitting the road. At its core, a self-driving car is a sophisticated blend of a machine, an AI brain, and an array of advanced sensors. This AI brain processes massive amounts of data in real time to navigate complex environments. Autonomy is measured in levels, from level 1 driver assistance to level 5 full automation. To see the world, these vehicles rely on a suite of sensors working in perfect harmony. LiDAR uses laser pulses to create a precise 3D map of the car's surroundings. High-speed cameras act as the car's eyes, identifying lane markings, traffic lights, and pedestrians. Radar and ultrasonic sensors provide a safety net, detecting objects in blind spots and varying weather conditions. All this raw data is fused together to build a complete 360-degree understanding of the environment. The result is a machine that can make split-second decisions with superhuman precision. But how do we teach a machine to handle the chaos of the real world? It all starts with data.
Training a self-driving car starts in the real world, where every mile driven is a lesson learned. From bustling city streets to complex intersections, the AI observes the intricate dance of modern transit. A suite of sensors, LiDAR, cameras, and radar, continuously records images, distances, and speeds. Every traffic light, pedestrian, and lane marker is captured as raw data for the AI to process. The system learns to navigate high-speed environments and maintain safe distances across millions of miles. But real-world driving isn't enough. We must also prepare the AI for the edge cases, the rare and dangerous events. Sudden stops, children crossing unexpectedly, or extreme weather are recreated in virtual environments. In these simulated worlds, the AI can face these risks millions of times without any real-world danger. This combined data creates a massive library of knowledge, allowing the AI to learn before it ever hits the road. By the time the software is deployed, it has already seen more than any human driver could in a lifetime. Moving into the heart of the process, simulation training. This is where the AI truly masters its craft. In virtual worlds, we can simulate millions of rare events in just a few hours. This dramatically reduces physical risk and accelerates the learning curve by orders of magnitude. Holographic overlays represent the AI's real-time decision-making process, evaluating every possible outcome. By analyzing heat maps and predicted trajectories, the system optimizes its behavior for safety and efficiency.
The heart of every self-driving car isn't its engine, but its brain, a complex neural network that never stops learning. Every second, these networks analyze massive streams of sensor data to identify objects and predict human behavior with millisecond precision. It sees what we see, but with perfect clarity, identifying every cyclist, pedestrian, and vehicle in its path. This intelligence is forged through iteration. The AI learns from every mistake made in both the virtual simulation and the real world. New data is continuously uploaded, retrained in the cloud, and pushed back to the fleet, a cycle of constant improvement. Transitioning from bits to bricks, the AI must first prove itself on closed tracks before ever touching public asphalt. Professional safety drivers act as a final fail-safe, monitoring every decision the system makes in real time. Emergency braking and high-speed obstacle avoidance are tested thousands of times in these controlled environments. Only after meeting rigorous safety benchmarks are the cars allowed to navigate the unpredictable chaos of public streets. Safety means surviving the edge cases, the extreme weather and rare events that challenge even the best human drivers. From blinding rain to pitch-black nights, the redundant sensor suite ensures the vehicle is never driving blind. With multiple redundant systems and exhaustive validation, we are building a driver that never tires, never distracts, and never compromises on safety. As development reaches maturity, we move from controlled tracks to the complex, unpredictable reality of our city streets. Gradual fleet deployment is the first step where AI-driven vehicles begin to integrate into the daily pulse of urban life. But these cars don't just drive, they communicate. Vehicle-to-vehicle and vehicle-to-infrastructure systems allow them to speak to one another. A shared awareness that extends far beyond the range of any human driver, creating a collective intelligence on the road. Even in the dark, the AI is calculating. Every stop is a demonstration of precision and pre-programmed safety. This isn't just a static system. It's a continuous feedback loop. Every mile driven is a lesson learned. The AI digests data from millions of scenarios across the globe, refining its understanding of every curve and intersection. With every journey, the system grows more resilient, safer, and more capable than the day before. What starts as a localized test soon scales into a global transformation of how we move. In the real world, safety isn't just a goal, it's the fundamental architecture of the AI brain. As the sun sets, the network remains active, silently coordinating the flow of the city. Seconds before they meet at a crossing, the vehicles have already negotiated their path. Back in the data centers, the collective experience of the fleet is synthesized into global updates. A single breakthrough in one car becomes an instant upgrade for every vehicle in the fleet. Efficiency is the byproduct of this coordination, reducing congestion and optimizing every route. Even the most difficult decisions are made in milliseconds, with a level of focus no human could sustain. But we are just at the beginning. The road leads toward a future we are only starting to imagine. We are moving toward level 5, full autonomy, a world where the car becomes a mobile living space. The next frontier is prediction, AI that can anticipate human behavior before it even happens. Global adoption means safer roads for everyone, everywhere. A new era of mobility defined by data. Imagine cities where traffic jams are a relic of the past and accidents are virtually eliminated. The digital brain will be the core of every journey, making trillions of decisions with invisible precision. Anticipating the unexpected, the AI ensures that every second on the road is governed by foresight. The future of driving isn't just about getting there. It's about a world that moves in perfect harmony. The AI is ready. The future is here.